That's a little bit far away. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. Sounds all right. Can't complain. Let's move on. Okay. All right. So let's get started. Kth largest sum in a binary tree. You are given the root of a binary tree and a positive integer k. The level sum is in the tree is the sum of the values of the nodes that are on the same level. So I believe we have 5, then we have 8 and 9, then we have 2, 1, 3, 7, which is 13, and then we have 4 plus 6, which is 10. These are the sums. Return the kth largest level sum in the tree. Not necessarily distinct. Okay, if there are fewer than k levels in the tree, return -1. Okay, makes sense. Note that two nodes are on the same level if they have the same distance from the root. Yeah. Duh. Okay, so pretty. All right. So, this exercise is not that hard, but we need to use two data structures. Very simple. Well, one is a list. That's a horrible spelling. List. And we can store the sums for each level. But the other one that is interesting is going to be a queue. Okay. Q. Okay. I don't know if I like this color. Let's try blue. Maybe blue is better. Whatever. In the list, we're going to store the sums of each level. Well, in the queue, we are going to add for each node we previously had. Okay. So let's say that we start with the root. So we add the 5. Okay. Then we remove the 5 and we add it here because this was the only thing. But before removing it, or let's say we save this node 5, we say, what are the child? What is the child, or what are the children of 5? 8 and 9. So we remove 5 because it's a queue, and we put here 8 and here 9. Okay. Then we parse the queue again. We remove 8. We add it to our local sum. And then we put 9 here. We add it to the local sum. And before removing them completely from memory, we go and look at their children. 1, 2, 3, 7. And we put them here. 1, 2, 3, 7. And now that sum is correct, we push it in our list and repeat the same procedure. So we remove 8 and 9. We do 1 plus 3 plus 2 plus 7. Well, that's more than a 7 than a 2. So, and then we're going to add our sum. And after we added all our sums for each level, basically we can just do a sort sum. And we just return k minus 1 for our sums. K minus 1 because the kth is like here in our list, we go from 0 to n minus 1. And if we want to return the first level, so the kth level, right, we have to return 0. Okay. So, but we will see that later. This is very simple. We just have to do a while loop while this is not empty, and then for each value inside our queue, we just have to grab them, put it in a sum. Then for each value, we're just gonna add more, how do you say them? Their children, and then push this sum into our list and repeat that until we don't have any more values in our queue. And then we just have to sort the sum and return the kth, so the, how you say it, kth minus one element. And yeah, that's it. So let's write some code. Very simple, very simple. Don't get scared with trees. So let's initialize our first data structure. We have a list. Let's remember that it will return a long. So let's use the long list. Okay, let's call sums equals new array list. That's it. Then we have to initialize our queue. So we have, what was the queue? I guess queue is gonna be of tree node, because we have to push each tree node inside. And it's queue equals a new, it should be linked list. Okay. Then on our queue, which is queue, we have to add queue.add our root. Okay, so we start with our root. So now while queue dot is empty, so while it's not empty actually, what do we have to do? We have to initialize our say our sum. So int sum equals 0. We can call it level sum just to make it a little bit more, I don't know, understandable, but you understand, right? This is the sum. This is like the temporary sum where we'll store the level, the sum of each node at the same level, okay? And then for the sake of it, let's just do an int n equals queue.size. Actually, this is very important because we want to enter in a for loop now, and this is maybe a little bit tricky. Less than n, I++, but we want to enter in a for loop, and we want to iterate in this for loop for each parent we have, right? Well, because then in the next iteration of the for loop, we're just gonna have our children. For example, in this case, we're just gonna iterate once in our for loop because we are just pushing 5. So we have to call the method poll, okay? But we have to assign this poll to a tree node, actually to like a variable tree node equals poll. Okay. Now that we have our poll, we can just increment our sum plus equal node dot val should be right, int val, yes. Okay. Now that we have this, we have to push the children of node. So let's remember that children are not always declared. Sometimes they can be null, especially if we are at the end of our tree. So let's just check that. If node dot left is not null, then queue dot add node dot left. Okay, we can copy this because it's going to be the same thing, but we have to just do right. Okay, and that's it. That's our basically our loop. The only thing we have to do is that after we calculate our sum, we push our sum in our array list. So sums dot add sum. Very confusing. And that will give us everything. Now we have to do one thing. So before doing anything, we know there's a little like catch. If there are fewer than k levels in the tree, return -1. So if k is greater than it should be yes, sums.size. Okay, and just return -1 because we won't have a kth level, and so the sum is not calculable. But if we do have k, then what do we have to do? We have to sort the sums. So we do sums dot sort. If we do just this, we're gonna have them from the smallest to the highest, which is not properly correct. So we're just gonna do collections dot reverse order, I believe it is. So it just basically means that we are gonna sort the sums from the highest to the smallest value, and then we return sums dot get of what value? K -1. Okay, and this should be correct. I probably spelled something wrong for sure. Linked. I know that it's never pronounced link. You go linked list, but there's an ED there. Wait, what? Int sum? Oh, oops. And that's it. Let's hope that this runs. Okay, it's running. We're getting the right value. Let's try and submit it. Okay, not the fastest, but works. I actually submitted it before and I was getting a little bit faster. Nothing too crazy. But yeah, this is how you do it. You technically can do it a little bit faster if instead of using a list, you use a queue, priority queue. And so every time you add a sum to it, it's gonna be immediately pushed towards the highest value, right? That was the exercise, and thanks for watching.